The first case that we're going to talk about is when you can separate variables. So this is probably the easiest case that you will ever encounter on differential equations, and these are of first order. So this is characterized by having something like this. So when you have d of y over d of x, it's equal to a function that is just made of x's and a function that is just made of y's, and they are multiplying. Okay, so they have to be in this fashion. Either multiplying or dividing, it's okay. If they're adding or subtracting or anything else, then you cannot use this method. So what do you do when you have something like this? So first we multiply both sides by dx, and by the x. Therefore these two cancel each other, and we have dy, it's equal to hx g of y dx, and now we divide by gx. So we have something like this. It's equal to this one. Now we can see that all the terms in this area are y, and this area, this side, it's in terms of x. So we can just integrate this in terms of y and this in terms of x. So let's suppose that we have something like, let's say that k of y, it's equal to 1 over j of y. Okay, so we can replace this one, and then we can have this one will pass to be k of y dy, it's equal to the integral of h of x dx. And then when we integrate both sides, we will have a k of y equal an h of x plus c. And this will be our answer. So now let's go for little examples. So first, a very easy example. So let's have d of y over d of x, it's equal to sine of x. So now first we multiply by dx. So we have d of y, it's equal to sine of x multiplying dx. Now we integrate both sides, and then the integration of dy is just a y. It's equal to the minus cosine of x plus c. And this is our answer.